Good day, folks. Welcome to Prize Mind Academy, where we bring brilliance to every lesson. This is the video number 4 under exam questions. Okay, so I wanted to look at the type of graph again. Remember, the type of graph that we looked at before was the velocity on exam 1. On this one, it is momentum versus time graph. So now let's see. The graph below shows how the momentum of car A changes with time, just before and just after a head-on collision with car B. Car A has a mass of 1,500 kilograms, while the mass of car B, it is 900 grams. Car A has a mass of this one. Car B was traveling at a constant velocity of 15 meters per second west before the collision. Okay, so we'll take west as negative. Can you see? Let me try to zoom out that for you. West is negative, then this one is positive. Can you see? Like that. Therefore, okay, can you see now this momentum here are positive? So it tells you that the block mass car A is moving in the east direction. Why? Because now can you see it is positive in the air? So this is before, this is during the collision, this is after the collision. So this is the contact time during the collision. Then since it is a momentum graph, this here will be the change in momentum during the collision. Okay, the change in momentum during the collision. It's gonna be these two are gonna be important when we do a FNet, in case they want the FNet. Okay, yes. Now take east as positive. Okay, take east as positive and consider the system as isolated, meaning we can use conservation of linear momentum. Now use the information in the graph to answer the following question. Calculate the 4.1 magnitude of velocity of car A just before the collision. Here we have what? Momentum of A. We have momentum of A initial. We have momentum of A final. But they want us what? They want us to calculate the velocity of A. So we have its momentum, we have its mass. They want a velocity or a magnitude of velocity. So this should be a very, very nice equation where you say now P is equal to mv. What is their momentum before? It is what? 30,000. Okay, 30,000. It's a mass of A. Remember calculating for A. Mass of A is 1,500. Then we want V. Is it 1,500? Can it? Yes, we want V. Then I'm gonna say 30,000. I get something like 20. I think so. But let me just confirm. 30,000 divide by 1.5. Let me not make myself a mathematician. But yes, I get what? 20 meters per second. Then you are done. They wanted the magnitude. In case they wanted the direction, we're gonna say east because it is positive. Okay, east. Cool. For 4.2, calculate the velocity of B. Velocity of B just after the collision. Okay, we know, and I already know the momentum of A initial, the momentum of A final. So what I need is I need to understand something. Okay, let me see. The graph below shows the momentum of car A in changes, blah, blah. Okay, what do they want? They want me to calculate the what? Velocity of B after collision. Velocity of B after collision. I'll say, okay, let me be in a position of saying sum of momentum initial is equal to sum of momentum final. Remember when we talk about moment DO, I don't like it when I do calculations in different pages. Remember, initial momentum says it is momentum of A initial plus momentum of B initial. It is equal to momentum of A final plus momentum of B final. So now, but now we already have momentum of A initial plus this one you do not have. So I can just say it is B, velocity of B initial. It is equal to momentum of A final I have plus MBV B final. Then should I be in a position of substituting? Yes. Remember, I choose east as positive. Therefore, what is the momentum of A initial? It is 30,000. Where do I take that 30,000? I take it from the graph. Here it is, 30,000. It is the momentum initial. Then plus what? Plus the mass of this one was how much? I forget this mass is 900. So I'm going to say the mass of this one, it is 900. Then the velocity of B. What is the velocity of B initial? They say now car B was traveling at a constant velocity of 15 meters west, and west is negative, so it is negative 15. Negative 15. Therefore, what is the momentum of A final? The momentum of A final, it is what? After the collision, it is 14,000. Can you see that? It is 14,000. 14,000. Therefore, plus 900 multiplied by V final. Then you should be in a position of knowing how to punch your calculator in this particular case thereof. You're going to say 30,000 plus into 900 multiplied by negative 15, then minus 14,000. I get an answer of 2.5 divided by 900. I get an answer of 2.7777, which is 78 meters per second. Is it positive? What do they want? They want the velocity. Can you see? They did not say the magnitude. They want the velocity. Therefore, I'll say now, very, very important, the velocity here. They did not say the magnitude this time. They say the velocity. Therefore, I need to say this is 2.78 meters per second. Sorry, 2.78 meters per second. What? It is positive. Therefore, if the answer is positive, I'm going to say it is moving towards the east. It is very important because why? For any of these formulas, you'll get a mark. Then you get a mark for substituting here, you get a mark for substituting there, the magnitude as well as direction. No direction, you lose you forfeit 1 mark. They say calculate the magnitude. Here they say the magnitude of the net force acting on car A. Can you see? Acting on car A during the collision. Remember here, this is the change in momentum of car A during the collision. Okay, this is the change in time. Okay, so they want what? F net. So this is very, very easy. Why am I saying it is easy? Because I can come and say this is for 4.3. F net change in time, it is equal to change in P. I choose this as positive. My F net, it is what I'm looking for. What is my change in time? What is my change in time? My change in time is going to be 20.2 minus 20.1. Can you see that? 20.2 minus 20.1. Now remember what is changing in momentum. It is P final minus P initial. Okay. Then I get something like P final, it is 14,000. You remember from the graph, minus 80,000, it is initial. Let us remember, rewind very well. Final, it is 14,000. Initial, it is 80,000. Therefore, the answer that I'm expecting, it should be negative. Why? Because now, if car A is moving towards the east, the east, and car B is moving towards the west, car B will exert a force on A that causes A to try to move towards the west. So A will experience a force in the westerly direction. Okay. So therefore, but now we choose east as positive. So it means now the answer that I should get should be negative, but I will convert it. F net is equal to, then I'm in position of substituting and saying 14,000 you minus 30,000 divided by 20.2 minus 20.1, which is the same as 0.1. Here you can say 0.1, it is also acceptable. You get an answer of how much? Negative 160,000 newtons. But now let's look at the question. The question asked us for what? For the magnitude. Therefore, the magnitude, you're going to say, therefore, F net, it is equal to 160,000 newtons. If they wanted the direction, you're going to say west. 1 mark, final answer. 1 mark here, 1 mark there, 1 mark for the formula. Then you are done. You are done. That's how easy momentum and impulse questions are, okay? Let us be in a position of getting full marks in the exam. So thank you very much, folks, for watching my video. I hope you enjoyed. Thank you.